Here is a video solution to a word problem that I had my Algebra 2 honors students work on just a few months ago. The unit dealt with conic sections, and the specific problem deals with ellipses. And so I gave my students a real-world problem that talked about the Oval Office at the White House, which is actually in the shape of an ellipse. And what they had to do was find the distance between the fireplace and the president's desk. And something that some people don't quite know about the Oval Office is that it's designed in an oval so that the president's sitting at the focus of the ellipse, which is where the desk is located. Whenever you're in an ellipse, at the focus, you can hear everyone around the room. So it's kind of a cool little problem where they can actually see how something they learned in one unit can be applied to the real world. So the segment I drew in blue is actually going to be the distance we have to find. Because again, the problem you're being asked is what is the distance between the president's desk and the fireplace. So there are some formulas that are important to know to solve a problem like this. First of all, knowing the equation of ellipse, which is this, assuming that the vertex, actually in this case the center, is at 0, 0. So we'll assume that this is our center right here, and treat this as if this was we're on an XY axis. Another thing that's important though for a problem like this is that c squared equals a squared minus b squared. So a is going to be the distance from the center to the horizontal endpoint. That's A. That's B. And this right here is going to be C. So in essence, we want A plus C. And that's why this is called analytical geometry, because you have to take the tools that you're given and be able to analyze the situation so that you can solve what you're being asked to solve, which is the distance between the president's desk and the fireplace. So we begin by solving the problem. So we know that the width is 36 feet. That means that 2a equals 36. Again, a is the distance from the center to either horizontal endpoint. So therefore, a would have to be 18. And that's actually what we call the major axis, since it's longer than 28. This way we call the minor axis, and that's represented by 2b, because b is the distance from the center to either vertical endpoint of the ellipse. So 2b equals 28 feet, so b equals 14. So now we know that c squared equals 18 squared minus 14 squared. And these formulas are derived using some very rigorous math, which won't be covered in this video, but students who have covered conic sections usually have seen that derivation. So we have a calculator app right here that allows us to figure this out. So 18 squared minus 14 squared so you see that's 128. So therefore, c equals the square of 128, which will approximately be, if we were to take the square root of that, we get 11.313. And we're asked around 3 decimal places. And again, the distance between the fireplace and the president's desk will be a plus c, since again, a is the distance from the center to either horizontal endpoint, and c is the distance from the center to either focus, and of course the president's desk is at the focus so that you can hear everyone in the room. So a plus c, 18 plus 11.313, so we get 29.313 feet. and that is the distance between the president's desk and the fireplace in the Oval Office.